Whoop. I hope that is already in the room.
Good morning, I'm here.
Thank you so much. Thank you so much. So let me say something brief about Ms. Fatu before I hand over the mic to her, a young woman who is well under 30, going by her achievement. She actually is the first Miss Geek in the history of Senegal, and the second Miss Geek Africa 2018. Deye Fatu is interested in disruptive technologies such as AI, Internet of Things, and blockchain. She is the current Innovation and ICT Project Program Manager at IPAR, that is Initiative de Prospective okay, something close to that. I think in my next life, I need to be able to speak French. She is the CEO of TSG Tech and the co-founder of the startup eWanak. She basically aims to represent women leadership around the world and is committed to working for the professional development of girls and women in ICT. That is a perfect voice that our ladies and young women would certainly love to hear today. Ms. Deye, please take over.
Good morning, everybody. Thank you so much, dear Winston. I'm very glad to be here with you. Greetings from Senegal. I am very happy to be here with Prof. Tom Ogada, Dr. Angela, Samuel. Thank you so much.
Welcome.
Thank you, thank you. Can I jump to the presentation now?
Please do.
Thank you. I'm sharing my screen.
Are you managing? Yeah.
Yes. Do you see my screen?
Yeah, I can see it.
Okay, thank you. Nice. Okay, I would like to talk to artificial intelligence for SDGs. My topic will be in the responsible AI for agriculture, using AI for preserving crops. The SDGs we would like to talk about are those of the eradication of hunger and poverty, but the main is hunger because the topic is about the preservation of crops after harvest. So my name is Deye Fatu Mboup. I'm a big data engineer and AI specialist, also an IoT analyst programmer and solar energy and satellite system certified. That's the summary of my presentation. We will first talk about the challenges, the solution, after the prototype, the test and results, and the perspectives. So before I would like to introduce the name of the project, which is the Smart Granary. According to IFAO, the majority of African producers lose up to 70% of their stocks due to lack of preservation system. Another fact, globally, we produce 2 billion tons of fruits and vegetables, and more than 1 billion is lost due to pests and excessive heat. In East Africa, economic losses in the dairy sector due to spoilage and waste could average as much as 90 US dollar million per year. That's if I were 2004 sources. The solution we find for this phenomenon is the smart granary. The smart granary is a smart device that will allow farmers to sell their fruits, vegetables, and cereals thanks to the ventilation and automatic watering systems that are triggered to cool these products when the temperature is unfavorable, basically. Our features are an automatic ventilation system, or a system watering automatic irrigation system, a solar system as energy to empower the device, a cloud platform with AI system for monitoring products with KPIs. KPIs means the key performance indicators on evolution of the production. Before talking about the impacts, I want to show you the MVP or prototype we have. Here you see the assembly of the smart device with IoT sensors here. The MVP 1 here and the MVP 2 better advanced with LoRa technology, the long range area that allows access to a network coverage that can collect data from the sensors in areas that don't have geographical coverage. And as you can see, we use recycled plastic materials to make our devices. That's our contribution to another SDG 6 related to environment. In this table, you can see the cloud platform. We collect data from sensors such as temperature, which is the most important to perform actions, such as alerting the farmer if the system fails, or automatically triggers the system remotely thanks to a predictive algorithm that only monitors this functionality of the device. The data collected after each day are analyzed and trained with a machine learning model that allows us to make the system intelligent or smart without using sensors that are already used as output variables to train the smart device. We already did tests with agricultures or farmers who grows different varieties of food like mangoes, tomatoes, and we was able to save 70% of their stocks while they were making a yield of 33. The importance of this smart granary is firstly for economic, we can increase the profitability, affordable selling prices for fruits and vegetables, the modernization of and automation of agriculture. In the social point, decrease the number of deaths due to the poisoning from various products and expensive products on the market. The eradication of hunger and poverty, and environmental, the sustainability products to renewable energies like solar panel, etc., the preservation of agriculture balance, and the protection of the environment against waste cloud. Our perspective, we would like to deploy the device with 100 large Senegalese producers. Within 6 months, we already started. And within 1 year, that 1,000 large producers across 10 African countries, African benefited. The second perspective is to have systems that trigger pesticides and have a drone for catching and processing to prevent parasitic infections of plants. The third is about the fundraising of more than $200,000 for the first deployment in sub-region and in Africa, and make the system intelligent without using connected objects or IoT through emerging technologies such as machine learning, big data, and artificial intelligence. That's what we are doing. We believe in this project. Senegal believes it, believe in it. Africa believes in that project, and together we must think green, build smart, innovate for change to better promote the sustainable development across Africa and all around the world. Thank you so much.
Thank you so much, Nde, for that eye-opening talk. It's such a beautiful event when you hear women in Africa, and especially young women, are actually venturing into the formerly called, quote, male field and building such beautiful technology. There's no technology as beautiful as automation using machine learning, and especially in agriculture, looking at how agriculture is the one that affects the most vulnerable within our continent. I loved hearing what you're saying and speaking, and it would be nice in time to also be able to interact with the smart granary. However, I would like to ask our audience to reserve your comments as we shall we shall listen to the next three speakers before then we open it up for questions and answers. But even as we do this, as we go to the next speaker, I would love to the thoughts be around to what extent have we deployed this, and how is it benefiting the farmer right now? And if it is not doing that enough, what do we need to do so that our technology really has benefit for that final user down at the community? Thank you so much. Now that Ms. Ndeye has set the pace, allow me now to welcome the next speaker. And the next speaker, I think Samuel will correct me, I hope that I'm not wrong, is Dr. Devota Nyambo.
Yes.
Something small about her. Devota is a lecturer at the Nelson Mandela Institute of Science and Technology, Tanzania. She happens to be one of three very powerful ladies from Tanzania that we have interacted with for a while now. We actually call them the Tanzanian Trio, three exceptionally young and powerful ladies. And this we call due to their focused approach to research in AI. At her age of under 40, she's a seasoned scholar in AI. She has conducted numerous studies around AI, machine learning, especially around agriculture. She's a postdoc in our AI4D Africa Scholarship Project, and also is a supervisor to one of our PhD students under the same project. In fact, our student spoke yesterday. She's Within the postdoc program, she's doing studies around leveraging multi-agent models for learning recommendations and improvement of farmer-to-farmer interaction in small-scale dairy. Should be the first one to speak out of the three, the Tanzanian trio. Devotha, please, welcome.
Thank you so much, Dr. Ojenge. I think I'm audible.
Oh, very much clear.
Okay, thank you for that wonderful introduction. And I'll quickly share my screen and let's see. Just a second.
Okay, that's okay.
There we go. I think it is visible now.
Oh yes, we can fit.
Yes, yeah. So good morning and good afternoon, everyone. I'm happy to be in this session. And thank you so much, Dr. Ojenge, for that wonderful introduction which you have given. From Nelson Mandela African Institution of Science and Technology, as already introduced, and I'm doing my research around small-scale dairy systems. And when we are referring to dairy, we are referring to those farmers who keep exotic breed or improved breed, not the local breeds, which are normally managed under pastoral systems. So this is specifically for those farmers who keep their animals for dairy purposes, and normally they are few in a household. So this concept around dairy systems revolve in the sense that farmers, they always try their best to improve milk yield. And milk yield in terms of a dairy system, it's like the key. More milk means more money and also good well-being for the household. So these farmers, they engage various practices, husbandry practices, to make sure that they are having the best outcomes. But the challenge that is revolving around the systems is the insufficient or unavailable extension services by extension workers. So as a result, some farmers are stuck in failure loops. That means they are not able to produce the amount of milk that they are anticipating to. And these unsuccessful attempts by these farmers can result to undermine the desire for farming, especially for new entrants. But if we look on these extension workers who we are mentioning that they are intended to support the farming system, these are like animal production experts or support who are hired by governments to provide advisory and also veterinary services in different cases. So there is a gap. There is an extension service gap which is observed, and it is a result of the small number of workers and the growing number of small-scale farmers who are trying to achieve the dairy farming process. So this has resulted into farmers relying on their base knowledge of dairy farming and also assumptions and heuristics. But if we look on the developments and the anticipations of governments, we are expecting to increase our milk yield, but also strengthening the extension service. So if we are achieving this, we are sure that we are going to reduce significantly the poverty levels and also deal with hunger and also improve the well-being of our communities. So from the agent-based modeling perspective, we see an opportunity where we can design or we can test optimal farm management practices or strategies in an abstract setting before we can apply them in the real world. So this proposes a case for a digital extension model where the farmers can interact and share their best knowledge in terms of how they can improve their milk yield. And when I talk about sharing experiences among the farmers, I mean experience which is revolving around feeding system and practices, breeding preferences, animal health and services, and also membership in different groups which can support the farming process. So in this approach, we see an opportunity where artificial extension workers can be achieved through reliance on the individual farmer's knowledge, learning and sharing experience in a farmer-to-farmer network. However, it has to be moderated by experts who are approved by the government. So in line with that, the postdoc that I am engaged in is looking onto an integration of about 4 aspects. The first one is generation of data set. The second one is on the development of a mobile app for learning recommendations. Basically, when you're talking about learning recommendation, we want to achieve a point where the farmers can be given recommendations on how they can quickly improve in terms of dairy production. Now it has to be data driven, based on what the data is telling us. How can we better advise the farmer? But also to have, on the other hand, a mobile app which can facilitate now the farmer-to-farmer learning approach. So with our proposition, the farmer can get recommendations from the system, which is data-driven, and also the farmer can access their peers to learn from one another. And then these two, the mobile applications, they are highly contributed by results of the agent-based modeling, which is trying to abstract the farmer-to-farmer learning approach, and also to test various strategies which can increase milk production. So in combination of all those, we intend to achieve what we anticipate in the project. So preliminary results on the agent-based modeling and simulation have indicated that there is a significant amount of learning which can happen in a period of less than 1 year. So we are trying to say, if we model, let's say, an interaction of farmer to farmer for 2 years, what are the chances that some farmers would have picked some new knowledge and have applied the knowledge to improve their milk yield? So simulation results have indicated that within a period of 290 days, there is a chance that we can improve, or we can have farmer agents improve their milk yield and move into better productivity. So what we're trying to see now is how can we now migrate or move these anticipations into a tangible output that the farmers can actually use to interact with their peers and learn to improve their milk yield. So the agent-based modeling, which is ongoing, is being enriched with new input data, and to also develop the end user mobile applications to be able to deploy our solution. So the main goal here becomes to achieve a farmer-to-farmer learning platform that can also recommend optimal strategies for the increase of milk yield below the achieved simulation time, which is 290 days. So the 290 days, like I mentioned, if you look at this graph, it is coming from agent-based modeling and simulation. But we are now introducing the recommendation part so that we can significantly reduce this number of days. So let's say in less than 290 days, a farmer can adopt new strategies which can improve their milk yield. So for the part of recommendation model development, we are having a significant improvement, or let me say updates, where we have been able to mine several rules. Currently, we are working with 414 rules, but we are significantly trying to reduce for the purpose of finding more strong rules which can be tested and validated before we can deploy them in the mobile app. But basically, this is to show you that we have a certain stage, or we have a good stage in terms of mining these rules, which can inform what the farmers can do in order to improve their milk yield. And then on the side of mobile application development, we are also basing our implementation in a production cluster based. And by production cluster, I mean that we group the farmers into homogeneous groups, so that when we are talking about farmer to farmer learning, then we are making farmers of the same production cluster to learn from one another. So when we see that farmers from the same production cluster can significantly improve by learning from one another, then we can open the door to allow the farmers learn from farmers from the other clusters. Now, the production clusters are mainly defined according to the level of milk yield. And so you can expect that majority of the farmers in the same group would have somehow production levels which are not so different from one another. But trust me, a difference of 1 liter of milk in a dairy production system is a very significant one. So if we are in the same cluster and I am producing 2 liters and you are producing 5 liters, there is something very big that I can learn from you, and before I can even get out to learn from others. So this is how the implementation is designed. And in this graph here, we can see the type of production features which we are considering in the cluster-based farmer-to-farmer learning approach. So we are also moving ahead with the prototype design. It is also ongoing, and the screenshots which you see here are some of the screenshots of the prototype. And you can see that our prototype is on Swahili language, trying to customize the solution according to the requirements which we obtained from the field, indicating that Swahili language is more preferred to implement this kind of a solution. So like here we can see Kundi 6, which means cluster 6. And in this cluster, it means every farmer, when the farmer is registering into the system, the farmer will be allocated into a predefined cluster. According to our preliminary results, the farmer will be allocated into a pre-existing cluster. And now within this cluster, this farmer can interact, can chat with some peers that the farmer can find relevant. We are still improving on this prototype, and I'm sure that at the end of the project, it will be very relevant for the farmers. So in general, we are done with data collection. We are improving our requirements. Data analytics is ongoing, but I'm happy to say that we have been able to produce 2 manuscripts, and one of them has been accepted for publication. The first one, the rule-based engine for automatic allocation of smallholder dairy producers in pre-identified production clusters. This has been accepted for publication. And the one uncovering service gaps and patterns in smallholder dairy production systems using a data mining is also ongoing towards a journal publication. Other topics that I am also engaged in the sense of artificial intelligence is on the part of agent-based modeling. We are looking on the surveillance of dengue fever in Tanzania and maybe in sub-Saharan Africa if we get best results. But we're also looking on the understanding the efficacy of integrated malaria control approaches, having Tanzania as a case study. We are also implementing deep neural networks for bone fracture diagnostics and to develop support systems. And we are also working on education systems, looking on how we can achieve a cluster-based teacher assistive tools for improving school performance for rural and marginalized children. We are also looking on some time series data analysis, which we're looking on forecasting TB incidences, having a case study of one of the infectious disease hospital in Tanzania called the Kibongoto. And we are also looking on customer experience, and we are working on the case study of the Tanzania Railway Corporation, trying to improve the data set aggregation and improve the customer experience as they are using the services of the Tanzania Railway Corporation. And we are also working on data set aggregation and improvement of maternal vaccine data sets. So in general, that is my focus in AI to mention, and also my updates when it comes to the postdoc project that I'm going on with it. So thank you for that time and slot. Back to you, Dr. Njenge.
Thank you very much, Nyambo. That was beautiful. Like always, it's nice to listen to the things that you guys are involved in out there. It would be lovely later to invite people to make comments. For now, I hold your horses, people, as we wait for the next speaker. And I would ask every speaker try to be within about 8 minutes so that we can manage the changeovers without having to breach the schedules. So far, so good. So next speaker online is Dr. Neema Mduma. Dr. Mduma is one of the Tanzanian tribe. She's also a lecturer at the Nelson Mandela Institute of Science and Technology. Again, at an age of under 40, she's a seasoned scholar, having done numerous research studies within the area of AI. She's our postdoc, again in the AI for the Africa Scholarship Project. And the title she's pursuing within the postdoc is Deep Learning Techniques for Early Detection of Crop Diseases. Neema, welcome.
Thank you very much, Dr. Njenge, for the nice introduction. Hello, everyone. My name is Neema Mduma, a lecturer at the Nelson Mandela African Institution of Science and Technology in Arusha, Tanzania. I'm also the founder of Bakishule Initiative, which aims at promoting science, technology, engineering, and mathematics to girls in secondary schools in Tanzania. Today I'll share with you my journey as a machine learning researcher. My education background, I studied Bachelor of Science in Information Technology, Master's and PhD in Information and Communication Sciences and Engineering. As academician, I teach, do research and consultations. I teach mobile commerce, data mining and machine learning for masters, and document engineering and information architecture for PhDs. I am very much interested in research related to artificial intelligence, data science, and machine learning. Currently, I am supervising postgraduate researchers who are doing research in the area of agriculture, health, governance, disaster resilience, and marketing. I am serving as a principal investigator in 3 AI-related projects at NMIST. The first one is Lacuna Fund in Agriculture in collaboration with Makerere University AI Lab, Namibia University of Science and Technology, and Caragro AI in Ghana. The aim is to develop machine learning data sets for crop diseases, including imagery and spectrometry data. The second project is funded by Data Science Africa with a focus of building capacity to students, researchers, and practitioners in the field of data science and machine learning in order to develop solutions for societal and industrial challenges. And the third project is funded by African Center for Technology Studies with a focus of developing deep learning techniques for early detection of crop diseases. I will talk a little bit about this ACT-funded project, in which we are leveraging the power of machine learning technology on detecting crop diseases. Taking into consideration of maize lethonecrosis and maize strike disease for maize, and black sigatoka and Fusarium wittris 1 for banana, which are highly affecting productivity in Tanzania. Currently, farmers and agriculture extension officers are using visible symptoms to detect these diseases. However, this poses challenges such as late diagnosis beyond recovery, which may result to significant loss of crops. On the other hand, there is a shift in disease diagnosis from traditional approach towards data-driven solutions using deep learning techniques. And this is attributed by the fact that deep learning techniques, when accurately trained, provide convenient solution to the problem as compared to traditional approaches. However, training deep learning models require a large amount of data, and developing countries are still lacking enough data to facilitate research activities in this field. Therefore, this project aims to generate data sets that will facilitate machine learning activities and develop deep learning techniques for early detection of maize and banana diseases. To achieve this, the project has 4 specific objectives. The first one is to collect imagery data in the identified sites where smartphones are used to capture images. The second objective is to develop deep learning model for detecting crop diseases. Third is to evaluate performance of the developed model. And the fourth objective is to deploy the model in a mobile-based application for stakeholders to interact with the developed approach. Currently, we are in data collection phase, and we have achieved to collect 648 samples for maize, including healthy, maize lethal necrosis, and maize strike virus samples. And 778 samples for banana, including healthy, black sigatoka, and Fusarium wheatgrass 1. And our target is to have the fully labeled data set of about 18,000 samples. The next step is to finalize data collection phase so that we can start data preprocessing for model development. At the end of this project, we are expecting to generate crop imagery datasets that will be publicly available for all researchers who will be interested to come up with innovative solutions in this area. Also, the project will develop a mobile-based application that will be used by smallholders, farmers, and agriculture extension officer to diagnose crop diseases. And project findings will be disseminated via different platforms, such as reputable journals, workshops, and conferences. Thank you very much.
Very nice, Dr. Dung. Lovely and short and precise. And it also paints a very clear picture of how much mileage such a young person has covered in the area of AI and machine learning. We'll reserve our comments as we go to the second last speaker within this category, and that is Dr. Judith Leo. Dr. Judith Leo is the last of the trio. She's also a lecturer at the Nelson Mandela Institute of Science and Technology. Again, she's a seasoned scholar at a very young age and has also conducted numerous activities or study activities around AI. And her title within the AI4D Africa Scholarship Project, where she's a postdoc, the title is an integrated AI, Internet of Things, and mobile app-based tool for early prediction and control of mycotoxin in grains. It's a case study, maize and peanut crops in Tanzania. Welcome.
Thank you so much, Dr. Ojengi.
Thank you.
Yeah,
welcome.
Thank you so much for a nice introduction. Yes, good morning and good afternoon to everybody. I'm Dr. Judith Leo from Nelson Mandela African Institution of Science and Technology, of course, which is in Arusha, Tanzania. My specialty is artificial intelligence. I'm very happy to be here to present today in this session of Women in AI. Yeah. In Africa, women are working hard to break even and improve their well-being and that of their families and the community at large. In addition, as it has been noted that more than half of the total workforce in the agricultural sectors are women who live in the rural areas. And yet, according to the report of UNDP, it has been noted that 6 out of 10 of the world's poorest people are women. The effect of this poverty in women includes hunger, diseases, lack of basic necessities such as education, and effective tools or mechanisms. Despite the potentials activities of women towards economic development, there's still lack of precise and cost-effective mechanism for early diagnosis, prediction, management, and control of the activities. Hence, the economic development and well-being have remained lower. Therefore, as you can see, there's a dire need for women to come together and explore potential techniques to solve these challenges that they're facing. And in this presentation, we are going to focus on the potential technique, and that is artificial intelligence, AI. There are several aims for women in AI, in Africa and also in the world at large. We're going to see these aims that they have. Most of the initiative that women we do like to put in place in terms of the women in AI is to facilitate understanding of the real challenges and the required solution from the women themselves. The other thing is to enhance automation of various activities such as in different sectors in agriculture, health, education, to mention a few. And also to develop appropriate early detection, control, and preventive mechanisms in the AI-based techniques. In addition to that, to be able to create public access data set in large quantities. And to wind up, is to be able to analyze faster with high accuracy and also enhance decision-making. As you can see, there are a lot of objectives that women would wish to achieve through the use of AI. As a young women in the community, have done several activities or projects or research in various sectors, include education, environment, and agriculture sectors. And most on this sector, I focus on the health aspect of them. This is because, as we know, our health is our wealth. And most of the time, a health woman or a health human being is the one who is able to work in different economic activities. Therefore, I'm going to take you through one by one, for example, in the education sector, what I've done. In the education sector, I've been able to develop early prediction of risk behavior among adolescent young girls, whereby through this development using AI and mobile phone, as you can be seen here, I've been able to prevent young adolescent girls from contracting HIV/AIDS and also getting early pregnancies. Just to briefly explain this. The other activity that I've done in my master's and in my PhD studies is I've been able to link the environmental activities. When I say environmental activities or data, I've been able to link the climatic data, that is weather data, for example, temperature, rainfall, humidity, with a healthcare data set such as cholera in this case, to be able to prediction of diseases with the linkage of the environmental factors. One of them was the weather changes. Therefore, this model or this tool can be used in interaction with other diseases in case those diseases are also having linkages with the environmental factors such as the weather conditions. And coming to ACTS as a postdoc, I'm doing or developing a tool with the integration of artificial intelligence, IoT, and mobile application to early predict and control mycotoxins in grains. And in this case, I'm going to focus on the maize crops in Tanzania. As it has been known that, reported that aflatoxins contamination is one of the biggest challenges facing Tanzania and the world when it comes to food security issues. And several outbreaks have been reported in Kenya, Tanzania, and other parts of the world. Therefore, it is very essential to develop such kind of system, because as it has been known that most women are in the agriculture sector. Yeah, to present more on this, what I'm doing and acts, the methodology that I've applied in this study is design science research methodology, whereby it is going to guide me from requirement identification, design development, and evaluation, as well as communication of the product in terms of publications. I've chosen this methodology because it facilitates improvement of the functional performance of each interface of each stage as I move from problem identification towards communication. Yeah, the following are the methods and tools that I've deployed. Under requirement identification, I've used mixed qualitative and quantitative approach, literature review. I've also collected a secondary data set of more than 500 data. I've used ODK, mobile phones, and recorder in terms of the data collections. And in terms of the design and development, I've used rapid application development methodology. In terms of the mobile application development, I've used MySQL database, Java and JSON. And in terms of IoT, I've used sensors. These are the biosensors which are going to sense the chemical combination of the aflatoxins in maize and microcontroller. And of course, I'll also use machine learning algorithm to be able to predict the different levels of mycotoxin in maize. And in this case, I'm going to predict 3 different levels of mycotoxins in maize: the higher level, the mediate, and the lower one. And when it comes to validation, that is the evaluation stage, of course, I've used the same as mixed qualitative and quantitative approach. And in this case, I'm going to focus on a certain case study in a certain area, whereby we'll use questionnaire and focus group discussion for the case. And also in terms of the tools, I'm going to use ODK, mobile phone, and the recorder. And currently, in the design and development phase, whereby I've finished the design of the tool, yet to develop the tool. Yeah, in conclusion, based on what I've presented so far, especially about women in AI in terms of the aim and what I've done so far, I've seen several challenges that are needed to be addressed at large so as to enable these solutions that are being produced in terms of artificial intelligence to break through and to be sustainable and be usable at large. Therefore, the following recommendation, one of them is creation of proper roadmap for AI adoption in Africa, creation of responsible AI and inclusivity culture, creating unified policies that guide AI ethics and data sharing. There's the need of effective data collection tools, since most of the AI solutions depend on this data. So you can see most of the African data set are not of good quality. Therefore, there's the need to make them effective, or the data collection tools need to be effective so that we can have quality data in this case. The other thing, there's the need of production of cost-effective AI tools, because as you can see, the focus that want these tools to be used is among women who are living in the rural areas, who cannot afford to buy very expensive tools to use. Therefore, we should come together and be able to produce cost-effective AI tools that will be able to be used by anybody, even in the rural areas. Yeah, with that conclusion, or with that recommendation, I would wish to say thank you so much for listening. Yeah, thank you so much.
Thank you so much, Dr. Leo. That was beautiful. The technicality of it was nice. The last message was also as powerful, that we focus on technologies which are easy to use and cost effective. Now we are going to break step a little. When you usually, from experience, I've learned that when we go into extolling the power of AI, that this kind of talk should always be tempered by talk usually given by a certain type of expert, and that is the ethical AI expert. What they're basically saying is they're highlighting some of the risks that come with the application of AI. Today, we are having only one person, that is Ms. Sonia Bestchat, who would be the one to caution us about the use of AI. And then for that reason, because she was only one, we thought it wise to include one more. And this is not a woman in AI, but a man in ethical AI. But his content is exciting. And if you listen for the next 8 minutes, the talk alone will be able to justify the breach that caused by ourselves, by bringing in a man in between the talk around women in AI. Professor Ryan Abbott is a professor of law and also health sciences at the University of Surrey School of Law. He's also an adjunct assistant professor of medicine at the David Geffen School of Medicine at University of California, Los Angeles. Look at that combination. The excitement about his talk for me has always been around the fact that machines can also be treated legally as inventors of patents. However, let it come from the horse's own mouth. Professor Ryan Abbott, please welcome for the next 8 or so minutes.
Oh, thank you very much, Doctor. It's very exciting to be here, and I'm sorry I don't get to be there in person, but it's really an incredibly impressive series of talks you've had. Fiona, do you think you could advance the slides? Fiona, can you hear me? And I apologize, my internet connectivity is not quite as great here as I would like it to be, and I can't seem to get the slides working directly. But if we don't,
that's okay. Fiona or Samuel, who has the slides ready?
If we don't have the slides because there's only a few minutes, I can just start talking and hopefully catch up. But no, it's great to see all of you doing exciting technical things with AI, and it is good to keep in mind some of those ways in which those development and use cases will impact ethics and the law. You know, those two fields not being entirely overlapping. There are ethical things that are illegal. There are legal things that are unethical. But with AI doing more, both in terms of its functionality and its adoption, it's never been more important to have in mind what ethics and the law have to say about AI. And some of the very interesting ways in which artificial intelligence behaving like a person presents some new legal challenges that really haven't been well thought out before. So Doctor mentioned, an AI behaving as an inventor. Some of you may have seen a paper in the journal Nature last year from a research team at Google. And this team at Google developed a deep reinforcement learning-based AI system that could automate chip floor planning. And that is the process by which components on a microchip are laid out, and how it is laid out affects its functionality in terms of things like energy usage and latency. And the team reported that whereas it takes a multidisciplinary team of human beings months to develop a new chip floor plan, this AI could make one in under 6 hours, and could do so in a way where the AI design chip outperformed the human design chips on all key performance indicators. Now, that raises a whole bunch of really interesting questions aside from the technical ones, like, what's the economic impact to a company like Intel that can now, dramatically improve the way it's designing chips, what's the social impact of something like that, where people have trained their whole lives to design microchip floor plans and now, are facing competition from a computer program doing the same thing. And there's all sorts of very interesting legal implications to that, including because chip floor plans are, what we call intellectual property. They are the sort of non-tangible thing that you can protect with things like patent and copyright protection, and for microchips, some certain particular sorts of intellectual property that are probably a little more nuanced than you want to hear about. But the gist is, you have AI now doing human sorts of things and in ways that present all new sorts of challenges. This hasn't gone ignored by policymakers. So the UK, for example, last year came out with their national strategy on AI and noted we were living in the age of AI and that the UK aimed to become one of the world's leading AI superpowers this decade. Many developed countries have passed similar industrial strategies with similar sorts of aims. But no longer just reports and national strategies. The European Commission last year published draft AI regulations. So for those of you who are familiar with something like GDPR, which is the data privacy regulations in the UK, it takes many years between the European Commission publishing draft regulations and draft regulations coming into force, something like 6 years. But this is the first major step in them doing that. And so all things being equal, in a few years, we would expect to see some binding rules in the European Union on the development and use of AI. And that has requirements, for example, like that there are certain things you just cannot do with AI, like citizen scoring or mass facial recognition in public places, although there are some exceptions for that. And then for high risk uses of AI, you have almost like a medical device compliance regime where you have to do very extensive testing and certification before you can market a product. And then for lower risk uses, you don't have that. Now, these regulations are being passed now specific to AI, but of course there are many rules that apply to AI use, just not in ways that people may have thought through clearly. So for example, if we're thinking about intellectual property and facial recognition, there's a company called Clearview that has trained an AI to do face recognition. Oh, perfect. Trained an AI to do face recognition on about slide 6, I think. Would be at slide, keep going. Keep going. Perfect. Right, here's a company, one more back. Here's a company called Clearview that's trained an AI on 10 billion faces to be used for law enforcement to recognize people. And there's all sorts of concerns about doing that, ethically and legally, and including prosaic things like whether it's copyright infringement for this company to take a photo that you've pasted on Facebook and use it to train an AI to recognize you for law enforcement. Next slide. Or just as AI is making new inventions, it's making works of art. This is coming from DALL-E, which is a new open access AI art generator. And where AI has been making this sort of stuff for decades, no one's really cared because it hasn't had commercial value, and now suddenly it does. And the law may or may not protect this sort of thing. Next slide. So Winston mentioned, in an effort to test the law, my research group has filed patent applications and now copyright applications for AI-generated content in jurisdictions around the world. And South Africa was the first country to grant a patent to us in July of last year. The AI is listed as the inventor of the patent, but the AI does not own the patent because an AI is not a legal person, so it cannot own a patent. And also it wouldn't really make any sense for an AI to own a patent. The person who owns the AI owns the patent. And that's pretty much how things work normally. If I'm a university professor and I invent something, my university owns my invention, not me. Or if I work for Google, Google owns something and not me. But what this does is say to businesses looking at using AI to do things like develop new chip floor plans, it doesn't matter whether you have a machine doing something in a person or a person. This is a socially useful sort of activity, and it's something we want to promote. So with only 8 minutes, and I think I'm already slightly over, there's a limit to how deeply we can get into ethics and the law and AI, but I hope this gives you a sense of some of the ways in which, law and ethics are struggling to deal with behavior, human-like behaviors done by machines, and how laws are evolving to try and promote socially beneficial outcomes for it. I just like ending on this note because this is a book I wrote on the subject that was just translated to Chinese. And The Reasonable Robot and the Law became Rational Robots and the Future of Law and Artificial Intelligence. And it went from Ryan Abbott to Ryan Albert. And I was disappointed at that translation. And then I saw that a human translator had translated it perfectly into Chinese, and that Google Translate was inaccurately translating it straight back into English in a way that didn't quite make sense. So don't worry, the AI isn't going to take your jobs yet as AI programmers, but it is working at getting there.
Thank you very much, Professor Ryan Abbott. Yeah, it's confounding. It's also, well, it's also trailblazing, and that is complementary. I think what you're working on is exciting. It would be nice to know how this scene would look like 10 years or 20 years from now, where probably it would even be negotiated that AI may then on the patents and not even the designer, because the fact that a machine learning algorithm, there are algorithms that are able to become better than they were formerly designed. Actually, that is the essence behind machine learning. So if the machine learning algorithm got better over time than the designer, than what the designer put in, then who do you give credit for that additional knowledge? Then those would be questions that are extremely difficult, and then they're also open for a lot of debate. But thank you so much for that part. I think Samuel and Fiona will confirm that we have reached a point where we can catch. Sorry, I know that I lost everyone because I've just seen my computer reconnecting. I don't know whether I can be heard. Samuel, Fiona, can you hear me?
Yeah, we can hear you.
Okay. So I'll just redo what I had spoken, that we can now take a break and discuss some of the things that have been spoken. And I can see Professor Gadi's hand is up. Let's hear what Prof has to say.
Yeah, very briefly. First is to indicate that Professor Ryan Abbott is part of the consortium that is managing the scholarship program. And he will be supporting also the complementary activities that we'll be providing to our beneficiaries, specifically on ethics and AI. So you will be hearing more from him. And of course, we look forward to engaging him further on the same. I think what he has given today is just like to provoke your interest, so that when you'll be conducting the 1 week long short course on AI, then you should be able to get a huge audience to follow the short courses. Number two is to take this opportunity to really thank the 4 presenters that have made their presentation this afternoon and this morning. And really to say a big thank you to them. Very motivating for young and upcoming women scientists. And I know quite a number of them from universities, undergraduate and also postgraduate are participating today in this seminar. And I just wanted to ask all of you as we conclude this session, as a parting shot, what type of advice, encouragement do you want to give to the young women outside there that have been listening to you? Otherwise, kudos, the great work that you people are doing.